Thank you for inviting me for presentation. I've already listened to the children's presentation, very exciting. Just give me a few seconds to bring in my slides. Thank you once again. I'm here to present my slides. My topic says integrating industrial and environmental biotechnology for decarbonization. And I will just touch a little on opportunities for Africa. Now, we have talked so much about decarbonization, and I'm already introduced. I want to thank every person in the studio watching and the organizer once again. My name is Ikechukwu Onwurah from the University of Nigeria, Professor of Environmental Biotechnology and Biochemistry. Very quickly, I will define decarbonization, which I believe many of you have already defined, in terms of reducing carbon in the environment with the sole aim of conserving energy and saving us from the problem of global change. This is a form of climate change. So let me quickly define biotechnology. And here I'm going to underpin microorganisms being involved, because we know biotechnology is already defined. Industrial biotechnology is talking about the application of these microorganisms, which are most consequence of synthetic biology, where we use them to produce the substances we need, especially for industry, which are beneficial. I'll quickly run through the slide because of time. So I will talk about environmental biotechnology of my presentation, because I address the question of decarbonization. So that highlighted microorganisms will be the center of our discussion. Now I'm going to dwell much about what we have done in order to contribute to the problem of excess carbon in the country. In our laboratory, we have been able to develop a system of microorganisms, of which slide you are watching now. It's a composition of maybe 2 or more organisms that can agree or work together. That is a kind of adapted microorganism that have been tailored to do a particular function, as the case may be. So this is a generalized innovation of our microorganism, which we have used to do 1 or 2 things, which I'm going to discuss. That will be our contribution to support this program, which is being embarked by our noble women in oil and gas. Moving ahead a little bit because of time, because I'm coming to explain 1 or 2 things about this integration. We have developed to use a particular combination of nanoparticles and microorganisms so that we can reduce the effect of excess carbon. So the idea of optimization in bioethanol production, which we have developed using this microorganism, Pistia crudiawesi, which is, we have typed, it's already conserved in the bank. So this organism, in combination of nanoparticle, is able to produce enough quantity of our bioethanol. In this case, we're able to reduce pollution during its production. We're also able to save energy costs in the production. So economically, it is viable. So what we need is for industries to tap into this innovation and run a pilot project and see how it can be scaled up using our waste. In this our experiment, we use banana peel. The yield in productivity of biofuel and then energy conservation is quite commendable. So this is one out from our laboratory that I believe, if backed on, will lead to a sustainable, even energy conservation. So the next one I want to run through quickly concerns the oil industry directly. In the case of mud waste, which have been deposited or thrown into the ocean in diverse ways. Now, what we have done is to use a form of bioremediation technology, which we call biochem to treat this drilling waste. And we're able to come out with this result, reducing oxygen 02 toxic unit to no observed effect when we tested the treated waste with our indicator organism, the Nsukka. We also found out that the carbon dioxide emission was equivalent to this per mole, which is very much reduced, 0.05 tons, the equivalent of global warming potential, which we have as 4.5 tons per 1,000 kg of mud produced, which it was measured in terms of CO2 emission. This is quite commendable. I'm not showing the whole process because of time. I've shown us a diagram of how or what processes that we took to achieve this, but it is achievable. The energy consumption in this place. So we move to this. This is where I would like to concentrate a little bit for industrial production, where we still use the same type of consulting in preparation of biosurfactants. Biosurfactants are wetting agents. They are chemically synthesized, but we try to synthesize it using biological agents. They are very unique properties. Biosurfactants are actually used for many things: product production, cosmetic, environment, in different forms. Each production has less energy demand by the method we use, using our consulting. Now, industrial application and role of biosurfactants is what is tabulated. Used in petroleum industry for enhanced oil recovery. It is used in environmental solution, in bioremediation, can emulsify hydrocarbons. We have done a lot of work using these surfactants. In the petroleum industry, it is also used in formulation of drilling mud. These drilling muds using biosurfactants are easily biodegradable, so that makes it very good. So this area is where I'm going to emphasize that to be buoyant, economically good for Africa. It's also used in trade. In a Biotechnology, precisely what is happening with this organism. This one using Pseudomonas species and Azotobacter. Two of them work as a supplying all the necessary raw materials. We produce the factor and other refractory products, which we can now separate by down processing. We have done a lot on this. We have isolated the biosurfactant with this organism, measure the efficacy or effectiveness of this process using what we call life cycle assessment. Now, the concentration of biosurfactant produced as measured is what I'm presenting in this table, 10.30 milligram per liter. Even though it's not much, but it can be scaled up depending on the concentration of the organism. So when you use Pseudomonas, which produces biosurfactant, and this Azotobacter, which does not, but they can cohabit. Azotobacter produces nitrogen source for this organism. So instead of supplying exogenous nitrogen, this organism supplies it internally by trapping nitrogen from the environment, converting it to the usable form to this organism that thrives in it and produces biosurfactant. So it is a sustainable process. It is published internationally And I believe any person that can use this consortium will really move ahead. So this consortium has been tested in diverse operations, even in the environmental remediation activities. Moving from this slide, we tested process using life cycle analysis. We looked at carbon dioxide emission, which is major key in global warming and acid rain. We also looked at energy consumption, and which tells us about economic value, and then toxicity of it and the hazard. So after testing all this, we discovered that the overall result in terms of global warming, acidification, and electric energy input, our buffer production using the combination novel microorganisms, the overall results show that it is sustainable due to nitrogen supplying capacity of azotobacter, with high economic potential, since the higher values of the market offset the low fermentation yield. It is relatively low in energy consumption. So we have a lot of advantage using this process. And here is where I stop because of time. For further references to the work, these are the references that you can consult. They are published internationally and they are utilizable. So in conclusion, this novel organism can be of high benefit to industries who will champion the production of biosurfactant. And biosurfactant can be produced in large quantity because Africa has a lot of foods, biological materials like rice husk, banana peels, and such vegetable that can be used in producing biosurfactant. So Africa can benefit so much by using this novel methodology to produce large-scale biosurfactant, which can be exported to other countries who do not have such natural products. I want to thank you, the organizers. So I thank the organizers, the WEOG, for packaging this presentation, giving me the opportunity to share my little experience in this World Decarbonization Day. I want to thank all those who have listened to this presentation. Thank you very much.